Okay, so today we're going to talk about this big word. It's so big that it didn't even fit on the smartboard. Hey, that's how big it is. This is disproportionation reactions. Okay, disproportionation. What that means is a disproportionation reaction involves the same chemical type as both the OA and the RA. So what happens is that first chemical, okay, is not only the OA, but it's also the RA in some cases. In other words, it's going to two different things on the product side. So how do you know a disproportionation reaction? Well, quite often in a disproportionation reaction, the reactant, there's only going to be one reactant, okay? That one reactant is losing electrons to one product and gaining electrons to a different product, okay? And you can quite often tell them because, like I said, there's only one reactant. And in a lot of cases, they're going to say the word disproportionation, okay? Some of the atoms or molecules of this chemical are gaining electrons while others are losing. So what you have to keep in mind is it's not usually a very simple reactant. It's usually a polyatomic ion of some sort, or it's got multiple atoms in it, okay? Because obviously, in some cases, like I said, it's going to be a little complex then, okay? So if we look at this one here, it says balance the following reaction in acidic conditions. The first thing you notice is it's only one reactant, okay? So that one reactant, we have to match that up with something on the right-hand side, and then once again, that reactant is going to have to match up with something, a different thing on the on the product side. So here we go, okay? You're going to do the same thing you guys did yesterday, okay? And I see people already started, so that's good. All right? So you're going to say, okay, well, let's see. HS2O3 minus aqueous goes to, well, what are you going to go to? Well, look, this reactant here obviously has an S and an H in it, okay? And over on this side, well, let's pick the first one, S8 solid. Okay, so you see the S there is matching up with the S over there. All right, so those two things to start with. Okay, now we're going to do exactly what you did yesterday. Okay, so a little bit more review here, a little bit more practice with this. The first thing is what? What do we need to do from yesterday? Help me out here. Huh? Balance the sulfurs, yes? Balance the things other than oxygen. So we're going to balance the sulfurs. I'm going to put a 4 out in front, yes? Okay, to balance the sulfurs. Then, what do I do next from yesterday? Add waters to balance out the O's. How many O's do I have on this side? 12, yes? Okay, so I got 12 O's, so I'm going to add 12 O's by adding waters. Now remember, this did say up the top here, under acidic conditions, okay? What do I do next from yesterday? Add H pluses, yes? Okay, now you got to be careful, okay? And this happened in your homework yesterday, so you might want to double check kind of a little bit, but you have to be careful when you got H's already here. So there is 24 there, yes? On this side, you already have 4 H's. So 24, 4, I'm going to add 20 H pluses here. Okay? So 4 and 20 is 24, 24. Do I have all the elements balanced, all the atoms and ions and all that stuff? Yep, I do. What's the last thing I need to do from yesterday? Electrons, right? So look, 20 positive. Don't forget, this is a 4 negative, so that's a 16 positive here. And I got 0 and 0, so let me add a 16 negative there. Okay? Good? Okay? Questions, guys? Okay, that's all you need to do, guys. Reduction, yes, obviously, because on the reactant side. Oxidation, well, what's going to be oxidized? Well, gee, let me see here. I guess the HS2O3 minus, because that's all I have, right? HS2O3 minus goes to, well, let's see, HSO4 minus now. Okay, so once again, what's the other thing that's involved there? Obviously, you know, that this has to be my oxidation. Once again, you're going to start by balancing the major atoms, not oxygens or hydrogens. I got 2 sulfurs here. I'll put a 2 here. Okay. We need to figure out the O situation. We got 8 O's on the right-hand side, right? 8. Here I got 3, so I'm going to add 5 waters. Okay. We need to balance out the hydrogens. Well, let's see here. That's 10, 11 hydrogens on the left side, and 2 here. So I think I need another 9 hydrogens. Okay. So is that right? Let's see. 2, or did, no, wait. 2 and 9, that's 7 plus. No, wait, no, that's not right. Is it? Let me try that again here. Just give me a second here. I'm having a meltdown here. 10, 11, yeah, 2 and 9 more, yeah? Right? And 9 more. 2 and 9 more. Yeah, I'm worrying about charges already. That's a little bit early. Okay? Then, electrons, of course. Let's see. 1 minus on this side, 0. On this side, I have a 2 minus and a 9 plus. So that's a 7 plus on that side and a 1 minus here. 7 plus, 1 minus. Now, this is where you got to be a little bit careful here. And this is where you get caught off guard a little bit. How am I going to get from 7 plus to a 1 minus? I need to add 8 electrons, yes? 7 plus, 8 negative, that's a minus 1, which is a minus 1, yes? Okay. There you go. Oxidation. Electrons are on the right side. That's probably a good thing, okay? And let's add them up. And before we add them up, of course, for my final redox reaction, I need to balance out the electrons. So simply taking this one times 2, yes? Okay? As always, you know, if you can't do simple, well, I shouldn't say simple. If you can't do the simplifying, as you go here, take your time, right? Left versus right, write it all out, and then start canceling stuff out. So let's see here. Redox. I'm going to have, you know what? I could probably do this if you're okay with this. Look, you're going to have the same thing. On disproportionation, those two are going to be the same because remember, it's involved in being oxidized, it's involved in being reduced. It's the oxidizing agent, it's the reducing agent. So it's going to be on the same side twice, okay? So if you want, we could just take care of that right now. I got 4 here, and I got another 2 times that, so that's actually 6 HS2O3 minuses. Okay, so I add this one and this one. Okay, maybe I am going to try and simplify this one. This one shouldn't be too bad. That's going to be okay by itself over here, and so is this here. Because remember, those are kind of 2 parts from the original equation. So those should be sticking around, I would hope. What you're going to be able to cancel is the waters and the hydrogens. Yep, what did I mess up? Oh, yep, sorry. 4 there. What you're going to be able to cancel is the waters and the hydrogens. Thank you. So here we go. I got 12 waters here, and 2 times 5 is 10 waters here. So 12, 10, 2 waters on this side. Okay. And then finally, of course, electrons are going to cancel, so I don't need to see those. 20 here and 18 here, right? So 20, 18, that's a net of 2 on this side here. And does that take care of everything? I think it does. Yes? Should be balanced. We can double check, and I encourage you to do that, obviously. Make sure you double check. So we got 6 H's, 7, 8. I got 4 there, and another 4 is 8, so the H's are good. I got 12 sulfurs. I got 8 and 4 is 12 sulfurs. That's good. I got 18 oxygens. Here I got 16, 17, 18. That's good. I got, what is it? I think that's it for that. Charges, 6 minus and a 2 plus. That's a 4 negative. Okay. And here, a 4 negative. Good. All good. Okay. So that's really the only difference. You're going to use the same one twice. Other than that, it's exactly like you did yesterday. Same steps, everything. Okay? Good? Yes? Okay. Okay, that's not too bad, eh? Balance following under acidic conditions. So let's move this up here a bit. All right. So NO2 minus. You guys can kind of work on this one here. You guys might as well start on this and get going here. NO3 minus aqueous. And if you want, you could even write down the other one while you're waiting, kind of thing. This NO2 minus, of course, has to go to NO gas. Okay? Just make sure you don't get confused, of course, with these two. Make sure you're working on one at a time here. But these are going to be my reduction and oxidation. I don't know which one's which yet. We'll find out pretty shortly here. Okay? So you look here on this first one, N to N, that's good. We've got 2 O's, we've got 3 O's. I'm going to add a water. I added 2 hydrogens, so I'm going to add 2 H pluses here. And let's see, that's a 1 plus there and a 1 minus there. So I'm going to have to go with adding 2 electrons over there. Okay, so it looks like to me that this is my oxidation here, and of course this is my reduction. Same thing on this one here. We got NO2 minus. I'm going to add a water. The N's are good. Add a water. Now the O's are good. Now I add my 2 H pluses here. Let's see. That's a 1 plus. That's a 0. So I'm going to add 1 electron here. And that should be good. Reduction. Okay. Balance the atoms first. Then balance the oxygens by adding water, balance the hydrogens, add them up. Don't forget, this is times 2 here. Top one's good. And you get your final redox reaction. Now, once again, don't forget, since the reactant's the same, okay, you're going to have, basically you're going to be able to add those two together there. So I got 1 here and I got 2 here, so that's a total of 3 NO2 minuses. And let's see. On this side here, you can write out NO3 minus aqueous and 2 NO gases. So that takes care of that and that and that. That's all the stuff that's done so far. And then once again, waters, right? We got 1 water there, we got 2 there, so I'm going to add a water to this side. So check, check, and 2H plus, actually 4H pluses. And 2 H pluses, so 2 H pluses over here. Okay, and that should be it. I'm going to skip the balancing the atoms, but 3 minus and a 2 plus is a -1, and there's a -1 there. I'm sure it's good. Okay, good? Yeah, no? Coffee break time? Sure. One more quick example here. This one's under basics, so this is good review from yesterday as well. Okay, so this is also good review. Is that good for everyone? Yeah. Okay. This one here, P4, pH3, and HPO2 there. So let's move this up here a bit. What do we got here? So once again, P4, your only reactant, goes to pH3 solid. Okay, I'm just going to do this one first. Now, this one you're going to need a little bit more room for, so I'm going to write a little bit smaller because this is under basic conditions. So we still need to add hydroxides in there too, right? So first things first, P4, 4 P's, balance those. Okay. Now, do I have to add O's to balance O's? No, I don't. How am I going to balance? Let's see here. I need 12 hydrogens, yes? Okay, so how am I going to add hydrogens? This is under basic conditions, so we're going to add 12 H pluses. And if I'm going to add 12 H pluses to that side there, remember it's under basic conditions, so I'm going to add 12 OHs as well. And if I'm going to add 12 OHs there, I'm going to add 12 OHs over here. Okay. Balancing wise, let's see here, as far as charges go, I got a 12 minus on the right side, and on this side, remember, these combine together to give you 12 waters, which is 0. right? So 12 minus there, 0 here. I'm going to add 12 electrons to this side, and of course I ran out of room here. So 12 electrons. Should have spread it out a little bit more, which I probably could do still. Let's see. Ooh, let's not do that. Okay, good enough. Anyway, 12 electrons to the left-hand side. Okay. The next one here, let's see. So that's your reduction, obviously. Oxidation. P4. Let me give myself a little bit more room here this time. And H2PO2 minus. All right. So once again, you got to balance the P's first. I'm going to put a 4 here. 4 P's, 4 P's. I need 8 O's, so I'm going to add 8 waters to this side. 8 O's, so 8 O's. I got 16 positive on the left side. I have 16 hydrogens on the left side. I have 8 hydrogens on the right side. So if I want to balance out the H's, I need to add, right? 16, there's 8. I'm going to add 8 more to this side here. And for every acid that I add, I have to add an equal base. So 8 H pluses, I'm going to add 8 hydroxides, which means I have to add 8 hydroxides to this side here. Okay? Left side, I have an 8 minus. This side here, I got a 4 minus. This is neutral. 8 plus, 8 minus. So 8 minus, 4 minus. I'm going to add 4 more to this side here. Okay? We'll add them up. We're going to multiply this by 3, of course, to get the same number of electrons that lost equals gained. Redox reaction, final one here. Once again, these two here, you can add together. Don't forget, you got to multiply the bottom one by 3, because there's a 3 out there, so that's a total of 4 P4 solids. And, all right, now it's up to you kind of how you want to do this. If you want to take this in a little slower steps, by all means you can, because otherwise you're going to have a lot of stuff to deal with here. If you kind of want to do this and write it down on the side somewhere, that's fine too. You got 12 waters here, 12 there, okay? You got 3 times 8 is 24. So 12 and 24 waters, 12 and 24, right, is 36, yes? In fact, you know what, I think I'm just going to write that down for right now. I have, so that takes care of these two things here. And I got 24 hydroxides. All right. I always get confused because it looks like 240 H minuses, which 24 hydroxides. Don't get confused. There's no such thing as H minus. Well, actually, well, anyway. On this side here, I got, let's see, 4 pH3s. That's going to be good. I got 4 H2PO2 minuses. That's going to be good. Sorry, 12, yeah. And 12. Okay. Then I have what? Okay. Once again, on this side here, that combined together, that's 8 waters times 3 is 24 waters. So 24 H2Os. That takes care of that. And I have 12 hydroxides as well. Okay. And then last step here, of course, like I said, these get quite lengthy. You're going to have to start canceling out some stuff that I didn't want to do last time because I was going to get confused here. So once again, my final equation here should be 4P4 solids, 36 waters here, 24 there, so that's a net of 12 here. 12 waters. So that's that, that, and that. 24 hydroxides here, 12 hydroxides there. So that is, let's see here, 36, 12 I mean. 12 hydroxides, yeah? Yes? 12 hydroxides. So that takes care of these two things. And then I got the 4 pH3 solid. And I guess we'll find out pretty quickly if we've done this right or not. And I always forget something, so let's see. Well, where do we want to start here? First of all, let's look at charges here. 12 minus, 12 minus, that's good. 16 P's, 4 and 12 is 16, so that's good. 24 H's, and another 12 is 36 H's. There's 12 and 24, that's 36 H's. 12 O's and 12 O's, that's 24 and 24. It looks good, actually. I did good. Yay. Except for your help with the multiplying thing there. Other than that, I did good. Okay? Okay? So that would be your redox equation for that one there. Lots of stuff to that one, obviously, right? I get that, but yeah. Okay? And once again, that's exactly what you guys did yesterday, except yesterday you didn't have the same reactant going to both things, both products, right? You had the reactant goes to one thing, and this reactant goes to a different thing. In your homework today, which you already have today, because I made a mistake and photocopied it in there, but in your homework, you're actually only getting practice at 2 disproportionation reactions. They're the top 2, it says right there, disproportionation. If you look at the bottom one, guys, that kind of looks a lot like what we did yesterday, okay? Now, except for, well, we'll have to take a look there, but yeah, no, I think they're all good there. So those bottom 3 are just more practice of yesterday's stuff, okay? So back to yesterday's things there, but the first 2 are what we did today, okay? Good? We'll give you a little time to work on that. You guys got about half a class left, so that's good. And